Hello students, welcome back to Vedantu JEE. Am I live? Am I audible? Please let me know. Let me check. I think we are live. Okay. Hi Giridhar. Yes, bacha, this session is for your mains, specially for your mains, looking at how the mains paper was this year. Okay? Keeping that in mind, this session has been designed. Hello Sri, hello everyone. Call your friends, we are live. Hi Nina. Okay, cool. So today we're going to talk about practical organic chemistry. As you can see here, as you can look at the title, again a very important topic. So let us discuss why is this important at this point of time. Okay, let's begin. So we are talking about some chemistry. This is a very fun GIF here. Hi Kamlesh, hi Nina. Oh, that's great, Nina. Beta, all the sessions which are scheduled are for your JEE exams. For board exam, we will again bring another series which will begin from next week. Right now, it's for JEE, but it will be helpful for your board as well, because we are taking into consideration your NCERT book. As you all are very aware that this year, the entire chemistry paper was exactly from your NCERT line by line. So, for your April attempt, it is very crucial that we have to cover each and every line of NCERT. Okay? Yes, bacha, the priority is mains. All this session has been designed for your mains, as you can see from the banner, from the title. My name is Durgesh, bacha. Hi, let's begin. And why is this chapter very, very essential? Okay, why is this chapter very essential? Because looking at the 2024 trend of your JEE. Okay, in each shift, at least 2 questions were asked from your practical organic chemistry, and I'm keeping aside the inorganic chemistry, the salt analysis part. 2 questions were asked in each of the shifts. So you can imagine like how important this session is going to be for you guys. Next is, this is the most scoring topic, because you just have to go through this once. In this 1.5 hour lecture, we're going to complete the entire organic chemistry part, the practical part of it, and you're going to score maximum marks out of it, because there are just direct questions asked from it. Okay, just direct questions are asked from it, and it cannot be ignored anymore. Okay, this is a very, very important line. This one cannot be ignored, bacha. Very important topic. Let us give emphasis to it. Please look at this slide and look at the importance of this topic. Do not miss out on this session. Okay, and before we begin, I need to again remind you guys that Vedantu is here to back you up with the bounce back series for the April JEE mains attempt. And if you are a very serious candidate, you can enroll with us in this 60-day program, because from now on to your April attempt, there are approximately 60 days left for you guys to take that attempt, right? Expected date is 4th April. So till then, we are going to make you guys full on ready, steady for your JEE mains exam. And if you want to enroll in this crash course, this is what this crash course include, bacha. All these things are included. You can enroll by clicking on the link which is in the description box below. If you're interested, you can take part in it. Otherwise, we will be teaching you the most of the majority of the things on YouTube as well. Okay? Now let's begin. And also don't forget to like the session, subscribe the channel, and also share the session with your friends. Let us begin. Let me also look at the chat box. Hi. Yes, bacha, this is for not the practical. This is for your theory exams. Even in your theory exams, there are questions asked from your practical chemistry. Okay? Yes, bacha, we are going to start from the very, very basics. Yes, that is true. Many students have come to realize about this topic only after the exam got over. So right now we're going to emphasize on this. We are starting for the April attempt from this topic. So you can imagine the importance of practical organic chemistry, and all the things that I'm going to discuss here, they might seem repetitive. They might seem that too easy. They'll never ask this. But bacha, the things which you ignore, which you tend to be like, yaar, why would I do this? I don't need to do this. ये पढ़ने की क्या ज़रूरत है? Those topics are constantly being asked in a JEE 2024 exam. Okay? ठीक है. Very good. Let us begin the session. The contents of the session, let us look at the contents. This is going to be a 1.5-hour lecture starting from now. We are going to read about separation and purification techniques, extremely important. Then we're going to read about qualitative estimation of carbon, hydrogen, nitrogen, your halogen, sulfur, phosphorus, oxygen, which means all the elements present in your organic compounds. We are also going to do the quantitative estimation as well as the qualitative estimation, as well as the test for all the functional groups, right? What is the test for alcoholic group? What is the test for phenolic group? As in JEE 2024 exam, all these things were asked, and hence we are going to prepare very well for the April JEE 2024 attempt. Let us begin. Okay. Yes, bacha, organic tests have been asked. I will let you know how often all these things were repeated in just one JEE 2024 exam. So we're going to discuss each and everything. Now, first of all, we will begin with the separation and purification techniques. Okay, this is a very important topic. In each shift, there was at least one question out of just this one topic. Extremely easy topic, so we should not ignore it. Okay, and why is the separation and purification important? Why is separation and purification of compounds is important, bacha? Because whenever we are preparing a compound, and you want to analyze it, okay, whether this compound has carbon, whether this compound is hydrogen, whether it has oxygen, nitrogen, how will we come to know? So first of all, before analyzing what your organic compound constitutes of, what does it have in its components, we need to purify the compound, right? Otherwise, the impurities will not let the tests happen in the proper way, right? So for the tests to happen in a proper way, we need to first of all purify those compounds. So we're going to learn about the purification techniques after you have extracted the organic compound naturally, or did you prepare the organic compound in your lab. After both these things, we're going to purify it using these techniques. Okay, the number first technique, before that, we need to know what is purification. So there are various methods to purify your organic compounds. Okay, this is an organic chemistry class, not your inorganic salt analysis. Remember that. Okay, so various methods are based on what? Why do we have so many separation techniques? Why can't we just use one technique and separate every compound? Why? Because the nature of every compound is different. So the separation technique depends on the nature of the compound and also the nature of the impurity present in it. Both of these things we need to take into account, and based on that, the separation technique is identified and used. Okay? The next is, finally, how do we know after we have separated the compound, okay, using various techniques which I am going to teach you here. Okay, then how do we know that the compound we have is pure? We know that by actually calculating its melting point or boiling point, right? So whenever we try to find out the melting point or the boiling point of a pure compound, the melting point, boiling point of a pure compound has a very sharp melting point, which means what? That it will melt at just one temperature. If it is 25 degrees Celsius, so it will melt at 25 and not at a range of temperatures. Okay? Very sharp melting points. That is the identification of a pure compound. Remember this very important thing. Okay? Next is, but the melting point, whenever you are calculating the melting point in a laboratory, you are viewing the thermometers with your eye, है ना? So you can make a mistake because we are human beings. We can make a mistake. It can be 25.1. It can be 85.2. But you are seeing 85.5. What you are reporting can be different because you are human. You can make errors. So therefore, to identify pure compounds, even new methods are there. Those methods include chromatographic and spectroscopic techniques. These are very amazing techniques, better than your melting point and boiling point techniques, to know the purification of the compound, to know how pure is your compound. Okay? Next, very first purification technique on your screens. The very first is crystallization. You've been studying about crystallization since your very smaller classes, right? Very smaller classes, you've been studying about this. Yes, bacha, organic tests are also asked, and if you want to ask me any questions, I'll be looking at the chat box, okay, and I'll be replying to each and every question of yours. In crystallization, technique is based on what, bacha? It is the most commonly used technique for the purification of solid organic compounds. Remember, for the solid organic compounds, we use this crystallization technique. Okay, and it is based on the difference in solubilities of the compound and the impurities in a suitable solvent. Okay, like your compound and the impurities will be soluble at a different extent. Meaning what? That probably you have an organic compound, so it will be soluble in some organic solvent, but your impurity can be ions like sodium or your hydrogens or your hydroxides. So those ions are soluble in your polar solvents like water, right? So there's a difference in solubility which we make use of in the crystallization technique. So what is the basis for crystallization? Difference in solubilities. Basis of separation is this, and it is used for the purification of solid organic compounds. Okay, now let us look at the technique. In this technique, what do we do? Look at this diagram. Okay, in this diagram, what I've taken, I actually make a saturated solution. What do? I have an organic compound with me. Okay? On that organic compound, I pour a solvent. I pour such a solvent in which my compound is what? Sparingly soluble. Remember, in which my compound is sparingly soluble. And after that, what I do? But if I increase the temperature, at higher temperature, it is highly soluble. Remember that. What kind of solvent I am using, in which my organic compound is sparingly soluble, but if I heat it, it becomes extremely soluble, which means what? After heating it, what we're doing, we are making a saturated solution out of it. Okay? So we make a saturated solution of the organic compound, and then what to do? Then just let it cool down. Then we let it freeze and cool down, and as it cooled down, the pure crystals of the organic compound are actually visible. Here you will get pure crystals of the organic compound, and here, bacha, you will get the impurity. After the what technique? This is the funnel technique, right? You are using a separating funnel for separating the mixtures. Correct? Correct? Beta, sparingly soluble means that it is not completely soluble, half soluble. Somewhat it is soluble, somewhat it is not soluble. Okay? Not completely soluble, not completely insoluble, somewhere in the middle of that. Okay? So this is the crystallization technique. Let me switch on the AC. It is extremely hot here. Okay, let us go. Now, after this crystallization technique, I told you that the impurities are found here, and this, where the impurities are found here, this is called the mother liquor solution. Always remember, this is called the filtrate and also the mother liquor solution. Okay? But what to do if the impurities are colored? Impurities mean kuch bhi gandagi in that, which we as unwanted. I do not want that. So those impurities can be colored as well. So how to remove the color? We remove the color by actually pouring it on a activated charcoal. What charcoal does? It absorbs the color on it, and hence your impurity become colorless. Solution becomes colorless. Okay? Sometimes what you need to do, sometimes you need to do repeated crystallization, back by back. Okay? Repeated crystallization is necessary for the purification of the compound containing impurities which are of comparable solubilities. Did you get this point? What did we discuss in crystallization? That it is based on the principle of difference in solubility. Solubility of what? That the solubility of your organic compound as well as the impurities will be different. This is the basis. Next thing what we did, we actually took the organic compound, tried to dissolve in a organic solvent. Okay, I tried to dissolve it in a organic solvent, and then what I found, in such a solvent in which it is sparingly soluble, then I heated the solution and it became a saturated solution, and then I tried to cool it down to form the crystals, and after the crystals are formed, I got the pure crystals, and the impurities are found in this funnel or the filtrate, or this is called the mother liquor solution. Here we get the impurities, and if because of the impurities your solution is colored, we can actually get rid of the color by pouring activated charcoal in it. So these are the methods. Okay? Bache are saying practicals are over today, but these questions will be asked in your JEE 2024 exam. This is not for your practical exam. This is for your April attempt exam. So please focus on this thing. Okay? Next, these are some of the examples. The major example that you should know is that the benzoic acid. What happens to benzoic acid? It is sparingly soluble in cold water but highly soluble in hot water, and hence we can separate benzoic acid from its impurities using the crystallization technique. Understood? Next, one technique is over. Next is sublimation technique. Again, you've been reading about this since you were very little kids. What happens in sublimation, bacha? It is a process in which your solid directly transforms into the gaseous state, right? There is no liquid state in between. It directly transforms into the gaseous state. This is called sublimation. So this technique is used to purify or separate those substances where the impurities are not sublimable, but your organic compound sublimes easily. So what happens, because your organic compound, you took an organic compound, okay, it happens in an inverted funnel like this. So what happens when you are heating the organic compound here, it is directly converting into vapors and then condensing and settling down over here. But your impurities, what will happen to the impurities? It will first form a liquid, right? And then it will form gas. Okay? So therefore they can be separated easily. What is the best example of it? All the sublimable substances like your camphor, your benzoic acid, your anthracene, all these compounds use sublimation techniques to purify from the impurities. Okay? Beta, adsorption means something to absorb. I mean, for example, consider my hand to be a substrate. Okay? A substrate means what? Some platform. Okay? Consider my hand to be some platform. Now what I'm doing, I am attaching organic molecules on my hand. Okay? When I'm making a bond on the surface, okay, I am not letting the organic compound seep into my hand. Okay? This is not absorbing. Absorbing means what? That it gets inside my hand. But adsorbing means what? It stays on the surface. That is called adsorption. Okay? I hope your doubt is clear. Okay, next, sublimation technique. Now next is a very famous, which is your chromatography technique, extremely popular. Okay, chromatography, as the name suggests, is from a very old Greek word. Chroma means bacha, color. Chroma means what? Color. Okay? So what happened? The chromatography technique was very first used to separate out the colored components of a plant. Okay? So that is why its name has been chromatography since then. Because we try to separate the colored components, the green components, leafy components of the plant. Okay? Now this technique is used for most of the compounds. This is the most common technique. Remember this. Chromatography is the most common technique. Okay? And it is used for everything. Everything means what? It is used to separate mixtures into the components, which means what? If I have a mixture of organic solvent, right? I have chloroform in it, I have acetone in it, I have benzene in it. So what do I have? A mixture of organic compounds. Now I want to separate it. How to separate it? Using this technique, right? If I want to separate a mixture of compounds, I can separate it using chromatography. If I want to purify a compound, I can do through this. If I want to test the purity, like how pure is my compound, I can again do through this technique, right? So this technique is very, very extremely useful, and this has been asked twice in your JEE 2024 exam. So pay attention to this technique. So what I have discussed till now, that this technique is the most common technique and used for all these things, okay? And this technique is actually of two types. Chromatography is of two types, that is adsorption chromatography and your partition chromatography. And what does it mean? I'm going to discuss it one by one. Okay, everybody got this thing? Everybody understood? Next, chromatography. In chromatography, what happens? No matter what kind, no matter is it partition chromatography or adsorption chromatography, in both these chromatographies, what I'm doing, I'm using two kind of phases, which means what? I have one stationary phase. Stationary means what? Something which is still, not moving ever. And the other is a mobile phase, one that is moving. So I have two phases in the chromatography technique every time, no matter what kind of chromatography. Okay? The stationary phase is the immobile phase, as I told you. Okay? And the mobile phase is the eluent. The another name for the mobile phase is called eluent. Remember this name. Sometimes this name also comes in exam. Okay? Is a moving phase. Okay? Now what happens? For example, it is based on the solubility of mobile phase as well as adsorption on the stationary phase. Now what is the principle in chromatography? The principle of separation. The principle is, for example, this is a column. I'm talking about your column chromatography. In column chromatography, I have a stationary phase. Stationary phase is generally made of your silica or alumina. Okay? Your silica gel or alumina. Okay? So this stationary phase, what does it do? It forms bonds. It forms bonds with your compounds. Okay? Here what I am doing, I am pouring a liquid solvent in here. Okay? So this becomes my stationary phase, silica gel. So silica gel actually becomes, what happened? One second, bacha. Yes, so what happens here? What happens? This is a stationary phase. So stationary phase actually stays still, and when I pour the compound on it from the top, what happens? That compound forms bonds with the stationary phase. Okay? Now it has formed bond and got stuck on the stationary phase. Now what I'm doing? Now I'm pouring the mobile phase on it. Okay? Now what I'm doing? One second, let me again get the pen. Yes. Now what I'm doing, I'm pouring the mobile phase on it, the eluent on it. Now what happens? I pour it slowly. Do not pour it at once. So when I pour it slowly, it is moving slowly through these pores. Because there are pores, so now the liquid will pour very, very slowly through these pores. Okay? Now when it is flowing through the pores, what is happening? It is taking some of the whatever solution that you did here, right? One second. Yes. So whatever solution you poured here, your organic compound, it is also going down with this mobile solvent. Okay? So what is happening? What is happening in this case? That there are two phases that you need to remember. A stationary phase where your organic compound gets stuck, but then you pour the mobile phase or the liquid phase on it, and then what happens? That the compound that was here stuck on the silica gel now starts slowly moving down. And how it moves down, it depends on how much soluble is your compound in the mobile phase. Okay? So it is again based on the principle of solubility as well as adsorption. Both of these principles are used in this technique. Everybody understood? Okay? So this is called the chromatography. Now I'm going to discuss all kinds of chromatography with you. The number first kind of adsorption. Adsorption means what? When something gets stuck on the surface. So that's what I call adsorb hona. है ना? That's what I call adsorption on the surface. Okay? So here what happens? The compound gets stuck on the surface, and in the number first category of this chromatography is the column chromatography. What happens in column? Again, as I explained it to you, there is a glass tube. In that glass tube, you fill silica gel. Silica gel is what? Solid. Just like how your dirt particles are there, right? So just like that dirt particles, there are silica gel particles, but they are white in color, correct? So you pour those particles in this tube, and this tube is actually closed from the bottom. Okay? And you fill up this tube till here. Now what you're doing, you're pouring your organic compound, whichever you want to test over here. See, your mixture of compound is here, and then above that what you poured the organic solvent, okay, which is your mobile phase. This solvent is your mobile phase. Ab bacha, this solvent can either be a liquid or it can be even gas. Always remember that. This mobile phase can either be a liquid or a gas. Okay? So now what is happening, as this solvent is moving down little by little, it is taken some of the organic compound with it to downwards, correct? So what is happening, can you see in the next image? A and B plus C get separated out, and after some more time, when some more solvent has passed through it, A, B and C, all of these get separated out. So can you see, with one technique what I am doing, I am separating these constituents and also purifying them. Can you see, A is here, B is here and C is here. So I have purified this substance. Okay? So this is how a column chromatography works, and the most common type of gel is silica gel or even your alumina. As I told you, even alumina is used. Okay? And the most readily adsorbed substances are retained near the top. Always remember this. Whichever substance is more readily adsorbed, which means what? It is most easily adsorbed, means what? It forms the strongest bonds with your stationary phase. So it will be always at the top of the compound. For example, A forms stronger interaction with the stationary phase. Remember that. A has strong interaction with the stationary phase, with silica, okay? And C has the least strong interaction, with the silica gel, okay? Let's move forward. Next is thin layer chromatography, another kind of adsorption chromatography. In column, what I did, I had a glass tube in which I filled a gel inside it. In thin layer chromatography, what happens, I have just like this a glass plate. I have a glass plate, and on that glass plate I coat. What am I coating? I'm coating a solution of silica gel or alumina on it. Okay? So I'm coating a solution of silica gel or alumina on it, and now what I'm doing, I'm placing that plate inside a jar and I'm closing that jar. Okay? And inside that jar, also on that plate, I have put a spot on it. What is this spot? This is a spot of the organic compound you want to separate. Okay? I've put a spot of the organic compound you want to separate, and now I put this plate inside this jar. Now I know. Wait a second. Most of you are thinking, ma'am, what kind of spot? What are we separating? I don't understand. I know. These techniques you will do when you will actually go to your bachelor's or master's in your chemistry lab. Okay? And very rarely students get to do these things till their 12th standard, in their 12th class laboratory. But what is happening? I'll explain it to you in a little bit detail. That briefly, okay, I'll explain it to you that what happens whenever you're preparing an organic compound. So, for example, you prepared an amine. You prepared, for example, C6H5NH2. For example, you prepared this amine. Okay? Now, with this amine, you also get some so whenever I'm reacting this, I might get some nitrogen coming out of it, or I might get some other materials that are forming, right? So there can be other impurities or other products that I'm getting that I don't actually want. I only want to separate this aniline from it. So what I will do, I will put a spot of the organic compound which contains all the products in it. So right now what I'm doing after putting it here, I'm trying to separate those products. Understood everybody? Voice is low. Abhi bhi, is it low, bacha? Is it better now? Is it better now? Can anybody tell me? Is it better? Can anybody tell me if it is better? Okay? So what are we doing? We did this. Okay? Understood this thing? Now next. Now when I'm putting in this jar, what is happening? In this jar, there is again a solvent present here. Okay? A solvent present here, and through capillary action, that solvent actually transfers above. Okay? Capillary action, so that solvent transfers above, and as that solvent travels, this spot also travels with it. For example, this spot was here. Now it has traveled this much distance. Can you see? So this kind of chromatography, it is again based on a stationary phase and a mobile phase. So this is again a what kind of chromatography? Adsorption chromatography, and this is called thin layer chromatography, and separation of vitamins is done through this, and even amino acids. Now what has happened, bacha? Now what has happened? The spot is here. Sometimes what happens, you can visibly see the spot through your naked eye, and you know how much the spot has traveled from this position to this position. Okay? You can see the spot, but sometimes what happens, that organic compound is not visible to the naked eye. So what can I do? I can take that strip. This is a strip, right? I can take this chromatography strip and put it in the UV lamp. And under the UV light, I can see the fluorescence. If the organic compound is fluorescent, so I will be able to see the fluorescence compound under the UV light. Okay? This is the second method of visualizing the movement of the dot. Okay? And sometimes what happens, sometimes it doesn't even work under UV light. You cannot see any spot in the UV light. Then what to do? You can actually take this chromatography plate and put it in a iodine jar. Okay? Here it is mentioned. In a iodine jar, I keep it, and what happens? So if the compound reacts with iodine, it forms brown colored spots wherever the spot is traveling. So you know how much the spot is traveled. Okay? So it color the organic compound brown. And even if all these methods do not work, then what to do? How to see the spot? Then in case of, for example, in amino acids, the spots are not visible. So how to see the spots? We actually spray this plate with a ninhydrin solution. Okay? With ninhydrin solution, we actually spray this plate, and then we are able to visualize the spot. Okay? Shall I move on to the next thing? Okay, next. Next is partition chromatography. So what was happening in the previous chromatographies? Which was that? Previous chromatography was a column chromatography, your thin layer chromatography. Those were an adsorption chromatography, where the stationary phase was a solid. Here what is happening? In partition chromatography, your stationary phase, bacha, is a liquid. Always remember that. Okay? So even your stationary phase is a liquid, and even your mobile phase, which is the traveling phase, is again liquid. So what will happen in this case? The famous example for partition chromatography is your paper chromatography. Okay? Paper, as we all know, is a solid substance. But how does it work in chromatography? So in bacha chromatographic paper, what is happening? It contains water trapped inside it, right? That chromatography paper, that paper is not ordinary paper, not paper which you scribble upon. Okay? That paper has water trapped in it, and water is what? Again a liquid. Okay? So what is happening? Your stationary phase is again a liquid, and your mobile phase, you are doing the same technique with your paper chromatography. You are taking the paper chromatographic plate and putting it in a jar just like this, and that jar bacha has what? Solvent in it. Okay? And you put a spot of your organic compound in it, and what happens after some time? Through capillary action, your solvent travels, and along with the solvent, even your organic compound, your dot travel. Can you see the dots are traveling here? Can you see the dots are traveling in this case? Can you see the separation of the various dots happening here? So what is happening in partition chromatography? Both the stationary phase and the mobile phase are liquid. So partition means what? Then your organic compound is actually deciding at every stage whether I want to be soluble with the mobile phase or whether I want to be soluble with the stationary phase. As we know, stationary phase is water, which is polar, right? So stationary phase here is polar, and whatever solvent you are using, majorly we'll be using some organic solvent. So this solvent will be organic. So what is happening? Your organic compound is actually switching places between stationary phase and the mobile phase and moving upwards. And because both the phases are what, bacha? Both the phases are liquid. That's why this kind of chromatography is called a partition chromatography. Correct? Hi, bacha. Next, terms involved in chromatography. Is my voice not clear at all? Is my voice not clear? Uchik Puchik, can you tell me? Uchik Puchik is saying I'm giving Dolby experience. Okay. I think I'm sorry about it. I think it should be clear by now. Okay, next. Terms involved in chromatography. Again, a JEE 2024 question. This is a JEE 2024 question. This exact question was asked, like, what is RF? RF is what? The full form of RF is retardation factor. So what is happening? I told you, when I'm using your thin layer chromatography or paper chromatography, I'm putting a spot somewhere here. I'm putting a spot 2 centimeter above the bottom line. Okay? And what I'm doing, and then I'm putting this plate in a jar. In that jar, there is some solvent present here. And through that solvent, what is happening through capillary action, that solvent is traveling upwards. And with that solvent, even the spot is traveling. So what I'm actually measuring, I'm measuring the distance traveled by the spot as well as the distance traveled by the solvent. Okay? So the ratio between these two, what is RF factor? Look at here. RF factor is the distance moved by the solute. Solute is what? Your spot. So distance moved by the spot upon the distance moved by the solvent is called your RF factor. Very, very easy. This easy question was asked in the JEE 2024 exam. Okay? And this factor's full name is retardation factor. That's the entire thing you need to know about this thing. Okay? Next is your gas chromatography. As I told you that in chromatography, the mobile phase can either be liquid or gas. So if the mobile phase is gas, then that kind of chromatography is called gaseous chromatography. Easy peasy again. Okay? And agar in this case, the stationary phase, if here is solid, then it is called solid gas chromatography. And if the stationary phase is a liquid, then it is called gas liquid chromatography. Okay? And the mobile phase, bacha, here used is a gas. Okay? And what is a gas? Generally, the gases used are your inert gases like nitrogen or helium or argon, okay, which do not react with the sample. And your separation of amino acids is done through gas chromatography. Okay? Now, this is gas chromatography. Again, what is the principle here? How much solubility of your organic compound is with the gaseous compounds, gaseous or the stationary phase. Okay? And the least soluble constituent will come out first, while the most soluble comes out at the end. Again, a very important point. Okay? And the gas chromatogram, this is called a gas chromatogram. You don't need to remember it. Okay? I've just attached it for your education purposes. This is not given in your NCERT, but you should know what kind of a gas chromatogram. Chromatogram means what? Whatever you are getting after analyzing the results. Okay? So this is called a gas chromatogram. It looks somewhat like this. It has all the peaks. For example, here your benzene was detected, here your toluene was detected, here your metabenzene was detected. Okay? So these are all your gas chromatogram. Only thing you need to remember is that the mobile phase is a gas and the stationary phase can be either liquid or solid. That is it. Okay? Now let's move on to the next process, which is your distillation process. Again, we've been studying about this process since our very lower classes, right? We've been studying about this. And now what happens in distillation? What happens? We take a round bottom flask. Everybody remembers this picture, right? We take a round bottom flask and I try to heat it. Okay, and what happens? And I attach this round bottom flask to a condenser. Remember? So here evaporation is happening, and here with the condenser there is some ice plate attached to it. So here rapid condensation happening, and after that condensation I can collect the substance in another flask. So this is the process of distillation. Everybody is aware of it. What is happening? What is happening? We are boiling the substance, right? So in distillation, only those substances can be separated by distillation which are volatile liquids. Remember, if it is not volatile, if I cannot make vapors of it, how will I distill it? So volatile substance, extremely important point. Number first point, only volatile liquids show distillation. Volatile liquids from non-volatile impurities, we can separate them. Next, the liquids having sufficient difference in their boiling points. What does that mean? Sufficient difference in their boiling points. It means what? For example, if I have a solution, I have a flask, and in this flask I have A plus B solution, right? And I want to separate both of them. Okay? And now the temperature difference between them is only like 10 Kelvin or 20 Kelvin. So what happens? The temperature difference is very, very low. So if I try to heat them, both of them will vaporize. Then how will you separate them, right? So the difference between the boiling point of the mixture of the substances should be high. For example, it must be 50 degrees or 70 degrees or 100 degrees or 300 degrees. So the difference between them must be really high in order to separate them. Otherwise, they will boil together and we cannot separate them. So these are the important points, that the volatile liquids can be separated. And the second is that they should have sufficient difference in their boiling points. Okay? And also only those substances can be distilled which do not decompose on heating. What I'm doing? I'm making this liquid into gas. How? By heating it. So if my compound gets denatured by heating it, or it gets decomposed by heating, then I cannot use this technique because my compound is already getting spoiled. What will I do by separation? So those compounds which do not get decomposed by heating, only they can be used for distillation. Okay? Next point. Next is distillation. There are various kinds of distillation. All these distillations were asked in your JEE 2024 exam. Number first is your simple distillation. What happens in simple distillation? But nothing. When there is a large difference in their boiling points, when there is a mixture of two liquids and there's a large difference between them, then I use simple distillation technique. What will happen? I will try to heat my liquid, and the one which has a lower boiling point will heat first and form vapors, and it will condense here, and after condensation it will get collected over here. So what is happening? The one which has lower boiling point is getting collected here, and the one which has higher boiling point remains here. So the two liquids are getting separated when they have large difference in their boiling point. Okay? And their examples are chloroform and aniline. Look at the difference in their boiling points. Its boiling point is 334 Kelvin and aniline's boiling point is 457 Kelvin. So I can separate it through simple distillation. Next is your ether and toluene. Okay? Next distillation is fractional distillation. Okay. Next distillation, bacha, is your fractional distillation. Now what happens? Now I've distilled the liquids which have a large difference in their boiling points. Now for the distillation of this case, now when the difference in the boiling points is bacha not so much. Okay, and they are what? They are miscible liquids. Miscible means what? I have mixed two liquids and they're totally soluble in each other. They look like they're just one liquid, but I know there are two. Okay, and they have a very low difference in boiling point. Okay, have the boiling points of them are very close to each other. Now what will happen? Now if I try to heat them, what will happen? Both of them will vaporize together. Both of them will form the vapors together. So how to separate them now? So in order to separate them now, I use this column. Can you see this column here? This column, bacha, is called the fractionating column. Can you see? This column is called the fractionating column. And what happens in this column? Now, when I heat the mixture of substances, the one which has a higher boiling point. What will happen to it? The higher boiling point will get condensed first. What will happen? The higher boiling point will get condensed here, because the vapors will rise and they will again condense, will rise and again condense. But the one which has a lower boiling point, it will actually, the one which has a lower boiling point, what is happening to this pen? One second. Yes. What is happening? So what will happen here, bacha? Am I visible and audible? Okay. And the one with the lower boiling point will get collected over here. Okay, I am writing here. Here will be the low boiling point mixture, and here it will be the high boiling point mixture. So high boiling point will get condensed quickly, while the lower boiling point will get evaporating and will reach the top. And after reaching the top, it has no other way but to go through this condenser and collect over here. So what I am doing in this case, bacha, I am again separating a mixture of substances which have very close boiling points. But by using this fractionating column, I am deceiving the liquids. Okay? And the one which has a slightly higher boiling point will keep on condensing over here. And the one which has a lower boiling point will keep on evaporating and evaporating. It will go here and it will collect here. So here I am getting the compound with the low boiling point. Okay? So this is actually the principle for fractional distillation. Okay? So this is again I've taught you each of the things. Now when you get the PDF, which will be shared in the Telegram channel, and if you have not joined, please go and join the channel. I'll be sharing the PDF, and it has everything that's written here. I've already explained it to you. You can go ahead and read it. Okay? Now next, fractional distillation. Yes, in fractional distillation, bacha, these are the columns used. I just showed you the fractionating column that was used. So sometimes what industries do at industry level, they actually keep successive columns like this. What do? They keep one fractionating column, 2, 3, 4, 5, 6. So they attach like a lot of successive columns in their fractionating column. Okay, and each successive condensation and vaporization unit. So this is a condensation and vaporization unit, and each unit is actually called a theoretical plate. Extremely important point. Each unit is called a theoretical plate, and commercially columns with hundreds of plates are available. Okay? See, everything I'm teaching you, it is entirely from your NCERT. I have left nothing from your NCERT, only I've added a few things. I've added few examples which are not there in your NCERT but asked frequently. So this is just like a mega box NCERT plus facts. So you don't need to study anything other than this lecture. That is my promise. But please study this lecture. Extremely important for JEE 2024 exam. Okay? Now next. Beta, that column is used because I just told you, somebody is asking now what is the use of this column. The use of, I just taught you, when the two mixtures that I want to separate, for example, this liquid is composed of A and, for example, this liquid is made up of, what is happening? Okay, this is making me irritated now. Yes. So what is happening here, bacha? Here I have taken a mixture, for example, A plus B of two liquids. Okay? And these two liquids have very close boiling points. Now when I try to distill them, make them separate, what will happen? If I try to heat them, because they have very close boiling points, they will heat together and form vapors together. Okay? Now I cannot separate them through simple distillation. What will I do? When the boiling points of these two substances are very close to each other, what is happening? Then I actually put a fractionating column in between them. So what is the function of the fractionating column? Now when, for example, A has plus 20 Kelvin higher temperature, higher boiling point than your B. So what will happen? Your A, which has a higher boiling point, will actually get collected over here. Okay? And the one which has a slightly lower boiling point will get collected at the top. Okay? Because what is happening? The higher boiling point is keep on condensing using this fractionating column. but your lower boiling point actually rises up to the top. Lower boiling point liquid rises up to the top and it gets collected in this conical flask. Everybody understood this? Okay. Next, next distillation, and these are some of the examples of where your fractional distillation is used. The most common example again asked in JEE 2024 exam is a distillation of crude oil in oil refineries, as in your JEE 2024 exam. Exact question was asked. I mean, look at the level of question. You cannot ignore one fact from your NCERT. These kind of examples are being asked, and this can be a very, very crucial differentiating factor in determining ranks, right? So do not miss out on these things. So whatever I'm highlighting are extremely important. Whatever I'm teaching is extremely important. Understand each and every concept so that you don't have to return ever to this video. Just understand it right now here in this class. Okay? Next distillation, next kind of. I have discussed two kind of distillation. Simple distillation, next was fractionating distillation. Fractionating was when the two liquids have very similar boiling points. Now for the steam distillation, what happens? When do we use steam distillation? When your liquid, whatever you're trying to distill, is actually insoluble in water. Remember, when it is insoluble in water, but it is volatile. Okay? But it is steam volatile. Remember what is happening when I'm heating it? It is becoming vapors, but those vapors are not soluble in water. So what I'm doing now? So I am actually using this technique. I'm heating this solution. So here I have again a round bottom flask, and in this I have a solution in it, and I'm heating this solution and I'm making vapors of it. Okay? Now to these vapors I'm actually injecting. To these vapors I'm actually injecting a spray. A jet spray of what? A jet spray of water, a steam water. Okay, water in form of steam I'm spraying. Now what is happening? Now the steam vapors and your organic compound vapors. Can you see? Are you getting this point? What I have done? I have taken an organic compound in a round bottom flask. Okay, and I try to heat it. And when I'm heating it, it is becoming into vapors because my organic compound is volatile. Because it has become vapors here, now to add to that vapors, I'm actually injecting. Here I'm injecting a steam, water steam to it. Okay, water steam to it. Okay, now what is happening? Now the vapors are more. Now there are organic compound ki vapors and also your water vapors. Okay, now this steam, what is happening? This steam will go upwards and it will condense over here and it will get collected in a flask over here. Okay, it will get condensed, it will get collected in a flask over here. Okay, now what is happening, bacha? Because I told you that the organic compound was insoluble in water. Now because it has condensed, it will form two separate liquids. है ना? Because it is insoluble. Like for example, imagine how oil is insoluble in water. Okay? And oil will form a separate layer on the top of water and the water is below it. है ना? In similar manner, they will form two separate layers. The organic compound as well as the water will form two separate layers, and we can then extract both the layers through separating funnel. Okay? Now I can extract both the layers through, and they are separated from water using a separating funnel. Okay? And the most common example of this, bacha, is, okay, this board is not functioning properly. So the most common example asked is aniline and water mixture. Again given in your NCERT, aniline and water mixture is the most common example. ठीक है? What is happening? What you are not getting? What are you not understanding? Let me know. Okay, this is your steam distillation. In steam distillation, bacha, what was happening again? So this was your flask. है ना? This was your flask. What I did to the flask, I heated this flask. है ना? I heated this flask. In this flask, there was a organic compound. When I'm heating the organic compound is converting into vapors. है ना? So now the organic compound is converting into vapors, and to this vapors I've injected another spray of water steam to it. Okay, so now here the vapor concentration has increased. Now in this vapor concentration I have two things. I have water vapors. What do I have? I have water vapor. Okay. And plus, what else do I have? Water vapor, as well as I do have another thing, which is your organic compound vapors. So I have, bacha, two vapors in this. Two kinds of vapors are present here. Okay. Now the liquids. Now the liquids, when the sum of vapor pressure due to the organic liquid. Now the organic liquid will have some vapor pressure. Correct. This will have a vapor pressure, for example, P1. Similarly, your water vapor will have again some vapor pressure, right? Now your water vapor, bacha, will again have some vapor pressure. For example, it will be P2. Okay. Now the total, what will be the total pressure? It will be P is equals to, which will be P is equals to P1 plus P2. Okay. P is equals to P1 plus P2. And we know, when do something boil? When something boils, what is the principle for boiling? The principle for boiling is when the vapor pressure of the liquid becomes equal to the atmospheric pressure, right? To the atmospheric pressure, only then the liquid boils. Okay? So at which temperature this happens? At which temperature this happens is actually called your boiling point. Everybody is understanding this or not? Everybody? Yes, bacha, we are doing qualitative analysis as well as your quantitative analysis. Okay? Okay? Now, bacha, what is happening? We have P is equals to P1 plus P2. Why? What is P1? P1 is the vapor pressure of the water steam. And P2 is the vapor pressure of your organic compound. Remember this. Okay? So, this is the entire steam distillation process. Understood? Now, next is your vacuum distillation. In vacuum distillation, what I'm doing? I'm reducing the pressure. Vacuum means what? Zero pressure. So, here what I'm doing, bacha? Here what I'm doing, I'm actually reducing the pressure. Okay? I am reducing the pressure. Okay? In vacuum distillation, I am using this funda. As I know that pressure and temperature are directly proportional to each other. Now, if I have reduced the pressure, I know that its boiling point will also get reduced. Okay? So, as you are reducing the pressure inside that flask, what are you doing? As you are reducing the pressure, the temperature is also, bacha, decreasing. Okay? Now, to purify the liquids, bacha, what is happening? Now, again, I have taken a round bottom flask. In that flask, there is a mixture of two organic compounds, A and B. Okay, in that flask there is a mixture of two organic compounds, A plus B, and I have reduced the pressure. Now these organic compounds which I want to separate actually decompose at high temperature. What is happening? These compounds actually decompose. If I heat them, they get decomposed or they get denatured. So what is happening? They are getting decomposed at high temperature. Therefore, if I give them a higher temperature, okay, if I'm heating them, and with heating them, what am I doing? I'm increasing the temperature. See, the dilemma here is, because I need to do distillation of them. To distill them, I need to convert them into vapors. This is a dilemma, understand? Okay? But if I heat this liquid will decompose. And if it decomposes, it is of no use to me. Okay? So what to do? Now, if I increase the temperature, this is getting decomposed. And if I do not increase the temperature, this will not convert into vapor and I cannot separate them. So, I need to lower the temperature, lower the boiling point so that their vapors form at a smaller temperature, at a lower temperature. How to do that? If I reduce the pressure, then automatically the temperature or the boiling point will also get reduced. So, now what is happening as I've reduced the pressure inside this flask, reduce the pressure, so therefore the boiling point of these liquids also has reduced. So now what is happening? At a lower temperature, this will form vapors. Okay? So now what is happening? Because I'm not heating it. For example, it gets decomposed at 50 degrees Celsius and its boiling point is 60 degrees Celsius. Okay? Its boiling point is 60 degrees Celsius. Okay? For example, remember this thing. It gets decomposed at 50, but it starts boiling at 60. Now I have to do something to reduce its boiling point from 50 to 40, है ना? What to do to bring its boiling point to 40 degrees Celsius? Okay, how to do that? By reducing the pressure. And if I'm reducing the pressure, the temperature also reduces, the boiling point reduces, and your compound is not decomposed because it has not reached 50 degrees Celsius yet. So vacuum distillation is used for those components where I need the temperature to be smaller. Everybody understood? Okay. Next is differential extraction. The last topic of your separation techniques, extremely easy technique. Now what is happening in this case? Again, I'm using the principle of solubility to separate the mixtures. Okay, as I know, as we are talking about the purification of organic compound, we know that organic compounds are soluble or more soluble in organic solvents because like dissolves like, correct? So now what I am doing, I have prepared some organic compound in water. Most of the reactions in your chemistry lab will happen in water. Okay? Now you want to separate it. What will you do? You actually add some organic solvent in the compound. Okay? So this is your organic compound. For example, you took a separating funnel. This separation happens in a funnel like this, which is called a separating funnel. And then you close the funnel from the below. Okay, you add your organic compound, whatever compound you prepared in lab, in your water solution. Okay, organic compound in aqueous layer, and then you add a solvent layer on top of it. Okay, solvent layer is basically your organic solvent. Any organic solvent, for example, benzene, okay, or your acetone, or any organic solvent that you want to, or your toluene, any organic solvent that you want to use. Then what you do, you have made these two layers. Now shake it. Now shake it very, very well. Now what will happen? Your organic compound will actually get transferred to this solvent layer. Why? Because it is more soluble in the organic part of it. Okay? Now what can you do? You can open this tap. This is just like a tap. You open this tap and this aqueous layer will fall down until the last drop of the aqueous layer. Then again you stop this here, and here you can actually collect your both of these compounds. Okay, everybody understood this part? Now what I'm doing, I'm again making use of the difference in solubility part. I've prepared an organic compound in aqueous solution. Now I want to separate them. Now what I'm doing, in that aqueous solution which I prepared, in that organic compound I prepared in water, I'm actually adding a solvent layer on top of it. The solvent layer is an organic solvent. Now I'm shaking this. Now what will happen? The organic compound which was here in water, because it is more soluble in the organic part, it will transfer into the organic layer. Okay? Now the both things are got separated. Your water layer is here, and your organic layer plus your organic compound comes at the top. Here it is your organic compound. Okay, because it is more soluble in your organic solvent layer. Everybody understood it? Okay, and what are the examples of a differential extraction? Very, very important. Iodine, which is sparingly soluble in water but highly soluble in CCl4. Okay, so iodine, if I prepared iodine in water and I pour CCl4 in it, then shake the mixture, because iodine is more soluble in CCl4, it will get transferred into the CCl4 layer. Okay, and then they can get separated like this in two layers, aqueous layer and the other layer. Okay, and bacha, somebody is asking what is the difference between solute and solvent. This is a very basic 10th class, 9th class, 8th class question. I'm not going to answer it. Please Google it. Okay, next, differential extraction we have completed. Now we're talking about qualitative estimation. What are we going to talk about in qualitative estimation, bacha? Here in qualitative estimation, what will happen? Okay. In qualitative estimation, for example, you've prepared an organic compound. That organic compound every organic compound contains a carbon and the hydrogen and the nitrogen, correct? Every organic compound actually contains carbon, actually contains hydrogen, actually contains oxygen. Okay? Carbon and hydrogens are fixed. Okay, but it can also contain oxygen, for example, your ketone or your alcohols, है ना? Or it can contain your nitrogen, for example, in amines, or it can contain sulfur, it can contain phosphorus. So how do we know? How do we detect what our organic compound constitutes of? What are the constituents of the organic compound? Okay, so that we will learn in the qualitative estimation to know what are the constituents of the compound. For example, we start with the detection of elements. Okay, after this we're going to talk about the detection of functional groups. Okay, detection of elements. So first detection is of carbon and hydrogen. How do we detect these compounds? Carbon and because we know every organic compound has carbon in it, that's why it's organic, and will have hydrogen in it. So how do we do the test? So what do? We react the compound, whatever compound we have, with the cupric oxide. Okay, we react carbon with cupric oxide and heat it, and then what do we get? We actually get CO2. Okay, and then what happens when your cupric oxide react with hydrogen? It forms water molecule. These are very important reactions. Okay, when carbon reacts with cupric oxide, it forms CO2. When carbon reacts with hydrogen, it forms water. Now, how to test that the gas released is CO2? As we all know, we've studied since we were very, very young kids. है ना? So when we, what do we do? But whatever gas is released in a test tube, है ना? What happens? The gas is released in the test tube, and then we transfer that gas to a lime water. CaOH2 is what, bacha? A lime water solution. We transfer the CO2 gas to the lime water solution, and what do we get? We get a calcium carbonate as a precipitate. Okay, and calcium carbonate as a precipitate, which means what? The solution becomes turbid. Turbidity appears in the solution. Okay, and how to detect the presence of water? We detect the presence of water by reacting it with copper sulfate solution, which is white in color, and it ultimately turns into blue in color. Extremely important reaction asked every year. Okay? Yes, bacha, this will help with all your exams, especially your JEE mains exam and also your board exam. Okay? Next, preparing sodium fusion extract. Next case. Now what we have discussed how to detect whether my compound has carbon in it or hydrogen in it. So I reacted it with cupric oxide, and then I transferred for the detection of carbon dioxide, I transferred it to lime water. And for the detection of the next thing, which was your water, I actually tried to react it with copper sulfate, which is white in color, and after the reaction with water, it gets converted into blue color copper sulfate compound. Okay? Now the next detection of elements, there are various other elements present in organic compound. For example, nitrogen, sulfur, halogen, phosphorus. How to detect their presence? So first of all, what? Okay, first of all, let's talk about organic compounds. All your organic compounds, no matter what organic compounds you've studied, for example, your methyl, for example, your HCN. What is happening to the pen? 1 second. Yes, okay. For example, your HCN. Okay. What is our next organic compounds? For example, your amines. Okay. For example, your C6H5NH2. Okay. All these organic compounds, what is common in them? The only bonding present in them is called the covalent bonding. है ना? Covalent bonding is present in them, which is an extremely strong bond, and these bonds do not show reaction in aqueous medium. So therefore, it is hard to do any analysis of any compounds when they are in their covalent state. Okay, so what is the first step for detection of compounds, for detection of elements? The first step should be to convert these covalent compounds into ionic compounds, because ionic compounds detection is easier to do in aqueous medium, to do in water medium, okay, which is the most common solvent. So therefore, we need to convert these covalent compounds into ionic compounds, and in order to convert them into ionic compounds, we do the sodium fusion extract experiment. In that experiment, what do? We react the organic compound. Whatever organic compound we have, we react it with sodium metal. That is it. We react it with sodium metal, and it gives different reaction with different elements. For example, when sodium reacts with carbon and nitrogen, it forms sodium cyanide. Okay, when sodium reacts with sulfur, it forms sodium sulfide, and when sodium reacts with halogen, X represents halogen, then it forms sodium halide. Okay, now the cyanide, sulfide and the halide which we have prepared after the sodium fusion extract experiment. Okay, now they are extracted by boiling it in water. That is it. Okay, so this is the only thing that you need to remember. We have detected carbon and hydrogen already. Now to detect for the presence of other elements, the first thing we need to do is to convert our covalent compounds into ionic compounds, because ionic compounds detection is easier. Okay, and to convert it into ionic compounds, we react it with sodium, and that reaction is called sodium fusion extract, and we form all these kinds of compounds. Now we are going to test them. Now we have just converted the R compound into a ionic compound. These are all ionic compounds. Okay, now we are going to test for the presence of each of the elements. So the first test is this test after the formation of sodium fusion extract. After we have formed the ionic compound, now all the tests are called bacha Lassaigne test. Okay, Lassaigne test after the formation of that sodium fusion extract. Okay, the first test is the test for nitrogen. So how do we know that our compound has nitrogen in it? Then we react it with the cyanide, because see, this is what we prepared, right? NaCN molecule. So this sodium fusion extract, this sodium cyanide, we reacted with Fe2 plus ions. Fe2 plus ions in means of, for example, with FeSO4 solution. In FeSO4, Fe is in +2 state. So what I am doing, I am reacting this Cn minus ion with Fe2 plus ion, and what I am getting, I am actually getting this hexacyanoferrate ion. I am getting this hexacyanoferrate complex. Now this hexacyano, what is happening, bacha? Now in this solution, I have also added some of H2SO4 to acidify the solution. Okay, to acidify the solution, I have added some H2SO4 in it. What is the function of H2SO4? I know H2SO4 is a very good oxidizing agent. Everybody is aware of it, right? H2SO4 is a very good oxidizing agent. So what it does, it actually converts some of the Fe2 plus ions into Fe3 plus ions. Remember that. Okay, now after this complex is formed, hexacyanoferrate, what happens? Some of the ions which were converted into Fe plus 3 by H2SO4, they again react with this complex and form this Prussian blue complex. Again, what is the name of this complex? Remember, very essential name. This complex is called ferrocyanide. Ferrocyanide. Extremely important name. This is called ferrocyanide. Okay, another name is iron 3 hexacyanoferrate. Iron 3 hexacyanoferrate. Remember this name. Extremely important names. Okay, this compound is Prussian blue in color, and when this blue color appears, it confirms that your compound has nitrogen in it. This is the confirmatory test for nitrogen. So what we have done till now, I took the Lassaigne extract, and in that extract I added H2SO4 and FeSO4 in it. Now what happened, that FeSO4 got converted into hexacyanoferrate, but some of the Fe plus 3 ions react again with this complex and form a Prussian blue complex, which confirms the presence of nitrogen in it. Okay, now again some important points are written here, bacha. The points are, this test is not given by compounds which do not contain carbon. Okay, if your compounds only contains nitrogen, for example your hydrazine. Okay, for example bacha, your hydrazine is NH2. This compound do not have any carbon, hence this will not show the ferrocyanide test. This will not form a Prussian blue colored compound. Okay, and this test is also not given by diazonium salts. What are diazonium salts? Who can tell me what are diazonium salts, bacha? Whenever to a benzene ring, what is attached to a benzene ring? N2 plus Cl minus it attached. This is called a diazonium salt. Okay. Now what will happen? This also do not give, even though it has a carbon here, it has a nitrogen here, still this compound will not show the Prussian blue complex formed with it. Why? Because this is a very unstable compound. This is a very unstable compound, and as soon as I heat it a little bit, this will go away. This will break off and it will get converted into N2 gas. Okay? This is the reason why diazonium salts do not show the Prussian blue color, and even any compound which do not contain carbon will also not show your Prussian blue color. Everybody understood it? Next, Lassaigne test for sulfur. So we have done the test for bacha. What all we have done? Till now we have done test for nitrogen. Now the test for sulfur is here. For sulfur, what did I do? I reacted the sodium sulfide with Pb2 plus ions, and also to acidify it, I added acetic acid in it. What did I add? I added acetic acid in it and also added lead acetate in it. Okay? So all these things I've added, and what I got, this is the very first reaction. Very first reaction to determine if sulfur is present. So what I did, I reacted the sulfide with Pb plus 2, and if I get a black colored precipitate, that black colored precipitate confirms the presence of sulfide ions. Okay, this is the first reaction. The second reaction, bacha, is when I react sulfide ions with this compound FeCN5NO. Okay, and then I get a violet colored complex. This again confirms the presence of your sulfide ions. Everybody understood it? Everybody understood it? This is called nitroprusside. This is called sodium nitroprusside. Okay? Sodium nitroprusside. Next, test for nitrogen and sulfur. Now, what did I told you? I told you when nitrogen is present, then that would be the test. If sulfur is present, what would be the test? But what would happen if nitrogen and sulfur are present together in the same compound? If they are present together in the same compound, then a reaction somewhat like this will happen when I'm making what? Sodium fusion extract. When I'm reacting, when I'm trying to convert my organic compound which was covalent into ionic, I was reacting it with sodium metal. Okay, so I'm doing that again, sodium fusion extract test. I'm reacting sodium with carbon, nitrogen, sulfur. What is the compound I'm getting? I'm getting a sodium thiocyanate compound. Okay, now this sodium thiocyanate react with the Fe plus 3 ions, and it actually forms a blood red colored complex, which is your iron ferrocyanide complex. Okay, so you actually thiocyanide complex, you get a iron thiocyanide complex which is blood red in color. In previous case, what you were getting? You were getting a Prussian blue color when I was reacting it with Fe plus 3 ions. But in this case, when I'm reacting it with Fe plus 3 ions, I'm getting a blood red colored complex, because in this case, sulfur and nitrogens are present together. Okay, now next, what is happening? If sodium fusion is carried out with excess of sodium, the thiocyanide decomposes to yield cyanide and sulfide. These ions give their usual test. Okay, and what is said here, ki if I take the sodium in excess, okay, if I react the same compound which is CNS, the compound which contains both nitrogen and sulfur, but this time I have taken the sodium in excess, then what will I get? I will actually get sodium cyanide and sodium sulfide as products. Okay, now these will show their respective reaction. This will show positive test for nitrogen and this will show positive test for sulfur. Only when this kind of compound is made, your thiocyanate is made, only then it will form a blood red colored complex. Everybody understood it? Everybody understood it? What is happening? Is my voice not clear? What is happening to the mic? Hello? Hello? Let me see what is. Is it better now, bacha? Can anybody tell me if it is better now? Is it better now? Next, lasagna test. So we have actually studied tests for nitrogen, for sulfur, and also when nitrogen and sulfur are present together, then it is forming a blood red colored thiocyanate complex. Okay. Now we are testing for halogens. In testing for halogens, again what I'm doing, I'm taking that sodium fusion extract which I made. What did I make in the sodium fusion extract, bacha? I made the organic compound which was covalent into ionic. After making the ionic compound, I added some concentrated HNO3 in it. Okay, I tried to acidify the solution with HNO3 in it, and to that solution, I added AgNO3 plus NaCl plus some HNO3. What I'm getting? If my compound contains chlorine in it, if the compound actually contains chlorine in it, then I will get a white colored precipitate of AgCl which is soluble in ammonium hydroxide. If my compound contains bromine in it, then I will get a pale yellow PPT of AgBr and which is partly soluble in ammonium hydroxide. Similarly, if I have iodine in it, then I will get a dark yellow PPT which is insoluble in ammonium hydroxide. So this is how you test for halogen. This is a test for halogens. Everybody understood? Next, if in the test for halogens, what I'm doing, if in the test for halogens, my organic compound which contains a halogen contains nitrogen and sulfur along with it. Now what will happen if these two compounds are present along with it, then they will form reaction and form NaCN or Na2S as we have studied, right? When nitrogen and sulfur are present, they will also react with sodium and form NaCN and form Na2S. Okay. Now what do these compounds do? They actually interfere with the test for halogens. Okay. These compounds, bacha, actually interfere with the test for halogens because these compounds also give white PPT when they are reacted with AgNO3. Okay. And you might believe ki yaar, because I'm getting a white PPT, it must be the PPT for AgCl. But no, that PPT is actually of your NaCl and Na2S ions. So these ions actually interfere with your test for halogens. Remember that. So how to remove these ions? How to remove these elements? Now how do we remove NaCl and Na2S from the compounds? By heating the lasagna test, by heating the sodium fusion extract with concentrated HNO3. So after I have heated with concentrated HNO3, these nitrogen and sulfur actually exit the compound and your compound is pure and it only has halogen in it. Everybody understood? Okay, next is test for halogens. More tests are there. So more tests is the next test. The first test is the AgNO3 test. So what I did, I reacted the halogens with AgNO3 and whatever colored PPT I got, if I got white PPT, it means it had chlorine ions. If I had pale yellow PPT, it means it had bromine ions. If I had dark yellow PPT, it means it had iodine ions. Okay, that was one test. The other test for halogens is called the organic layer test. What happens in organic layer test, bacha? For example, this is your, what is happening here? I'm really sorry. I will not use this studio tomorrow. This is creating problems. I can see people are saying that my voice is also not clear. Beta, salt analysis will happen after this lecture is over. Okay? Salt analysis will happen. Next is the test for halogens. In the test for halogens, the next is organic layer test. In organic layer test, what happens, bacha? For example, I react the Br minus ion with chlorine gas. Okay? In here, I take the solvent CS2 or even your CCl4. What I'm doing, I took the sodium fusion extract which I made to make the compound ionic, and in that extract I added CS2 carbon disulfide and carbon tetrachloride in it, and to that I added some chlorine in it. Okay, so after I've added some chlorine in it, bacha, so after I've added some chlorine in it, what I'm getting? I'm actually getting Br2 and a Cl minus ion. So when the Br2 is formed, we all know bromine is formed. Bromine is of orange color. So that's how I know that the compound has bromine ion in it. And if I react the same sodium extract fusion, for example, organic compound has iodine in it, and if I do iodine plus Cl2, I get a violet colored iodine solution from it. So this is how, this is again a test for halogens. Next test for halogens is the Beilstein test. What do? I take the organic compound of whatever fusion I have made, the sodium extract fusion, and I try to heat it. I try to heat it on a Bunsen flame in a copper wire. Okay, I'm heating it in a Bunsen flame, and when I'm heating it, it will create some light colors, some flash, correct? So for example, if I'm getting a green flash, the green flash symbolizes that my compound has chlorine in it. If I'm getting a blue-green flash, that symbolizes my compound has bromine in it. And if I get a blue flash, it means I have iodine in my compound. Okay? And fluorine is not detected in this test. These all things are extremely important. Do not miss out on these things. Okay? Next is the test for phosphorus. Bacha. What is happening in the test for phosphorus? So your sodium phosphate, when it reacts with HNO3, it actually forms your H3PO4 and NaNO3. Okay? And the next is when this H3PO4 actually reacts with ammonium molybdate. When I try to react with the ammonium molybdate, what I'm getting is a yellow colored. This is bacha yellow colored ammonium phosphomolybdate I get. Again, an extremely important reaction. I have nothing to explain in it. This is just how the reaction takes place. So how am I testing for phosphorus? I'm taking the phosphate, whichever I've made, the phosphate that I've made, I'm trying to react with HNO3, and whatever H3PO4 I'm getting, I'm trying to react it with ammonium molybdate. And after, if I'm getting a yellow colored complex form of ammonium phosphomolybdate, that confirms that my compound has phosphorus ion in it. Everybody understood? Everybody understood? Yes. Was that question in your JEE 2024 exam? Somebody is saying that this question was in JEE 2024 exam. Okay. Now the test for functional group, we have come to the end of this session. The test for functional groups, which is again extremely important. Okay? The functional groups, whatever functional groups are present in your organic compound needs, how do we know that whatever compound I have in my hand? For example, whenever a teacher gives me an organic compound in my lab, I cannot see and tell that it is an alkene, or it is an alcohol, or it is an ester. I cannot see and tell, right? So how do I know what kind of functional group is attached in that compound? So for that, I actually do tests for functional group. Ask repeatedly in your JEE 2024 January session exam. So hence this is very important. Now for the first test that we are going to study is a test for unsaturation. The very first test is a test for unsaturation. Okay? Unsaturation means what? Whether your compound has a double bond in it or whether your compound bacha has a triple bond in it. Okay? This is called the test for unsaturation. The first test is the bromine water test. Okay? In bromine water test, bacha, what is happening? I react your alkene. It can be an alkene or an alkyne. Okay? I am reacting with Br2. I am reacting it with Br2 as well as your water. Okay? Plus here will be water. Okay? Now, because I know that Br2 bacha, it is reddish orange in color. Correct? Br2 is reddish orange in color. Now, to that bromine solution, I'm adding an alkene in it. Okay? Now, what I'm doing, because bromine and alkene react together, it will form a addition product. That addition product bacha will be colorless. So, what is happening? Your reddish brown solution is actually converting into a colorless solution. So this confirms the presence of unsaturation. It can be an alkene or it can be an alkyne. Okay? Similarly, bromine in CCl4. So what is happening in bromine in CCl4, bacha? For example, I am reacting the alkene. I am reacting the alkene with again Br2 bromine solution, but right now the solvent is changed. Here the solvent is water and right now here the solvent is CCl4. Correct? Here the solvent bacha is CCl4, and from the reddish brown color I'm actually getting a colorless solution. Same reaction as we did before, that the bromine water, which is reddish brown in color, is getting converted to a colorless solution. So this actually confirms that my compound has a unsaturation in it. It can be alkene or alkyne. The next test for unsaturation is the Bayer's test. Okay, Bayer's test. This test is only for alkenes. Only for alkenes. What happens in this test, bacha? This is your alkene. When I react alkene with Bayer's reagent, what is Bayer's reagent? Your KMnO4. It can be alkaline, or it can be neutral. Okay? Your alkaline or neutral KMnO4 solution is actually purple in color. Okay? But when I react your KMnO4 with an alkene, what happens? This kind of oxidation happens and it gets converted into a vicinal diol. Can everybody see? This is getting converted into a vicinal diol. है ना? Vicinal diol, and this purple color actually changes to again a colorless. This MnO2 again is a colorless solution. Okay, so this is again a very good test for unsaturation. This test works for alkenes. What I do, I took a purple color KMnO4 solution, and when I pour alkene in it, that purple color changes to colorless solution, which confirms that my compound has unsaturation in it. Correct? Correct? Next is AgNO3 in ammonia. This is a determination of terminal alkene. This kind of reactions is also constantly asked in your JEE exams. Terminal means what, bacha? For example, this is my alkene. What is happening to this board? Okay. For example, bacha, this is my alkene. C. So whenever a triple bond is present at the end of the chain, that is called a terminal alkene. Whenever it is present at the end of the chain, it is called a terminal alkene. So how do we know the reaction of terminal alkene? Bacha, the very first reaction is, I react the terminal alkene with AgNO3 in ammonia solution, and I get a silver mirror kind of product. This product is actually silver in color, which actually confirms that your alkene was terminal alkene. Next is the acidic nature of terminal alkyne. As we know that the terminal alkyne has what, bacha? A H here, hai na? And this H is really acidic because it is attached to a sp carbon. Remember, because it is attached to a sp carbon, this hydrogen is very acidic. And to test the reaction of this acidic hydrogen, I react it with a base, sodium amide. Sodium amide is what, bacha? Sodium amide is a very basic compound. So when I react it with a base, what happens? It forms a sodium acetylide compound, which again confirms the presence of a terminal alkene. Next is the reaction with Grignard reagent. Again, your terminal alkenes react with Grignard reagent and forms a alkane group. So whenever an alkane is formed, it confirms the presence of a alkyne group in it. Okay, next is your steric ammonium nitrate test. What is next, bacha? Steric ammonium. Now we are back to the alcoholic group test. Test for alcoholic group, which is your ROH group. Okay, how do we test? How do we know my organic compound has a alcoholic group in it? How do I know that? By reacting it with steric ammonium nitrate test. Sabse pehla, very first test is I react it with this compound. Okay, and it forms a red complex, and if a red complex is formed, it means that my compound has a OH group to it. Okay, next is the alcoholic groups are of various types. They can be primary, secondary, tertiary. How to differentiate between them? Which is the primary alcohol? Which is the secondary alcohol? Which is the tertiary alcohol? Which is the aromatic alcohol? So all these distinguishing tests within alcohols. So this first test is used for all the alcohols. If it is alcohol, all the alcohols will give this test. Now to distinguish whether my alcohol is primary, secondary, tertiary. Now I know whatever organic compound I have has alcohol in it. But what kind, what degree of alcohol, then I will use these kind of tests. Number first test is the iodoform test. What all compounds give iodoform test, bacha? Whenever there is a methyl group attached, right next, methyl group is attached on the alpha carbon of the hydroxyl group. Alpha carbon means what? The carbon right next to the group where your functional group is attached. So this is called the alpha carbon. If on the alpha carbon there is a CH3 group, very, very important. Only methyl alcohols give this test, iodoform test. What happens in iodoform test? In the end, CHI3 product is formed, which is yellow colored, pale yellow color compound is formed, which is a very antiseptic smell kind of compound is formed, which confirms that your alcohol is a what? Is a methyl alcohol. Okay? Methyl alcohol, just like this. Next is your Lucas test. Lucas test, very important test, asked in JEE 2024. I don't know how many times. Asked in JEE 2024, very, very important, and mostly all of the shifts it was asked. Lucas test mein what happens, bacha? The Lucas reagent is actually ZnCl2 plus your concentrated HCl. Okay? This is your Lucas reagent, HCl plus ZnCl2. Okay? What I'm doing? I'm reacting my alcohol. Okay? If it is a primary, can you see this is a primary alcohol, this is a secondary alcohol, and this is a tertiary alcohol. Okay? Now if I'm reacting my primary alcohol with the Lucas reagent, what I'm getting? No reaction or a very slow reaction. Okay? But if I'm reacting secondary alcohol with Lucas reagent, I am getting a alkyl product. Can you see there's an alkyl halide form? There's an alkyl halide form, and this alkyl halide is formed within 5 minutes of the reaction. Okay, within 5 minutes. And with the tertiary, this reaction, bacha, is super fast. Super fast, it means what? It happens instantaneously. So what is happening? Your Lucas reagent is reacting. Your Lucas reagent is reacting with the primary, secondary and tertiary alcohol. With primary, the reaction is very slow. Very slow means what? It can even take days. It can even take days to form an alkyl halide. With secondary alcohol, within under 5 minutes, the reaction happens. Okay? And your alkyl halide is formed. And with your tertiary alcohol, your alkyl halide is formed instantaneously, super fast. Now, in the Lucas reagent, what is Lucas reagent? ZnCl2 plus HCl. In that Lucas reagent, your alcohol, all of the alcohols, whether it is primary, secondary or tertiary, all of the alcohols are soluble. Okay? But the product form, here the product form is a halide, alkyl halide. The alkyl halide is not soluble in the Lucas reagent. Okay? So what happens? With the primary alcohols, the layers do not separate. With secondary alcohols, because this alkyl halide form is not soluble, this alkyl halide form is not at all soluble in the reagent. So what will happen? It will form two layers. Here is your reagent and here is your alkyl halide and here is your reagent. So two layers are formed within 5 minutes of the reaction. And with tertiary alcohol, bacha, what happens? The two layers are formed of the reagent and of the alkyl halide are formed instantaneously. And with primary, the layers do not separate because there is no reaction, and we know that alcohols are soluble in the Lucas reagent. So this is the test. This is a test for ROH group to identify. This is how we can distinguish between the primary, secondary and the tertiary alcohols. Okay. Next test is the Victor-Meyer test. Again, with this test, we can distinguish between the primary, secondary and the tertiary alcohol. What do we do? When I react primary alcohol, the reagent in Victor-Meyer test is bacha, phosphorus plus iodine. Remember this. Okay. Now what I am doing when I am reacting primary alcohol with the Victor-Meyer reagent, what I am getting? I am getting a alkyl halide. What am I getting? I am getting a alkyl halide plus AgNO2 solution. Okay, I am getting this. Now this alkyl halide, I am reacting it with AgNO2 solution, and with AgNO2 solution I am getting a alkyl nitrate with it. With this alkyl nitrate, I am again reacting it with HONO solution. Okay, and then in the end I react with NaOH solution, and there is a blood red color compound form. Okay, so these are all the reagents which you need to remember. The reagents are P and I2. Number first reagent. Number second reagent is AgNO2. Okay, number third reagent is HONO. Number 4th reagent is your NaOH. So this is all, there's like a chain reaction going on. These all are the reagents used in your Victor-Mayer test. Okay? In Victor-Mayer test, if you are getting blood red color, it means you have a primary alcohol with you. But if you are getting a blue color, it means that you have a secondary alcohol with you. And if you are getting a colorless solution, it means that you have a tertiary alcohol with you. Everybody got it? Everybody understood it? Everybody understood it? ठीक है? One second. One second. Okay, next is a ferric chloride test for the aromatic hydroxides. Okay, now we did the test for alcohols. We did the test for alcohols which were aliphatic alcohols. Now we're doing for the phenols. This is the test for phenols. Remember, phenol test. Number first test is the ferric chloride test. How do we know that a compound that I have is a phenol? So I reacted with ferric chloride, and if I get a violet colored complex, it confirms that my compound is a phenolic compound. Okay? The next is, if my phenol can be a resorcinol. Resorcinol, bacha, means what? Resorcinol means this. One second, I'll draw the structures. Resorcinol is again a phenolic compound, but your OH are attached at the meta position. This is a resorcinol. Okay? Similarly, ortho, meta, para, crysols means what? Chrysol means whenever. When, for example, this is a OH group, and with respect to the OH group, if the CH3 is at the ortho position, this is a orthochrysol. Okay? Orthochrysol. Similarly, if the CH3 with respect to the OH group is at the meta position, it will be metachrysol. Otherwise, it will be parachrysol. Understood? Okay? And catechol, so resorcinol, ortho, meta, parachrysol gives violet or blue coloration. Remember this. Similarly, your catechol is, bacha, what? Catechol is a orthophenol. 1,2-diphenol. This is your catechol. Remember these structures, very, very important. Okay, your catechol gives green color or it immediately darkens up, and your 1,2-naphthol do not give any characteristic color. So this is a very important reaction for the phenolic group. Now the next is a phthalate dye test. This again is very important. This was asked in your JEE 2024 exam. Remember this. This was again asked in your JEE 2024 exam. Okay? Yes. Are there any questions? It was asked, bacha, twice in like 2 of the shifts. This same question was asked. Like what was the question? Let me rephrase it. The question was, what is the test for the phenolic group? That is it. And one of the option was your phthalate dye test. Can you imagine? The level of the question was so easy. You just need to know the name of the test. That is it. So phenolic group test is the name of the test for the phenolic group is called the phthalate dye test, right? So what I'm doing, I'm taking a phenol and I'm trying to react it with phthalic anhydride. What is this, bacha? This is called phthalic anhydride. Okay? So what I'm doing, I took a phenol and tried to react with phthalic anhydride in presence of concentrated H2SO4, and the product that I got there, this product is called, bacha, your phenolphthalein dye. What it is called? It is called your phenolphthalein dye. Okay? This is, bacha, is called your phenolphthalein dye. Now, as we know, when I put phenolphthalein dye in a basic solution, it turns into pink color. Okay? And if I add more basic solution in it, it will turn colorless again. Okay? So this is again a very good test, a very, very extremely good test of your phenolic group asked in your JEE 2024 exam. Okay? Next is this phthalate dye test. What are the colors given by this phthalate dye test for various phenolic group? If the phenolic group is orthochrysol, I just told you the structure of orthochrysol. See, this is called the orthochrysol structure. Okay? This orthochrysol gives red colored compound. Metacresol gives bluish purple colored compound. Paracresol gives no color. Remember these colors. Why? Because the JEE 2024 exam has become extremely factual exam. Remember this, based on the trends. These information which usually students skip, they will never remember these names. They will just skip this page of the NCERT, but do not do that, because this can be a differentiating factor. Remember the color of the compounds form, because they directly ask questions like this. So every line in NCERT is extremely important. Next is catechol. Catechol, usually the color is blue, but it takes longer time to appear, and with your resorcinol, fluorescent green colored compound is formed. Okay? The next phenolic group test is called your bromine water test. Again, when you add bromine in phenol and bromine, as we know that bromine is reddish brown in color, right? Bromine is reddish brown in color, and when it forms a compound like this, right, it has formed this compound will again become colorless compound. So what is happening when I'm adding phenol to a reddish brown bromine compound? It is forming this addition product and the solution becomes colorless. This is again a confirmatory test for the presence of your phenolic group. So these were all the tests for your phenolic compounds. Now we have come for the test for aldehydic and ketonic groups. So what are the tests for aldehydic and ketonic groups, bacha? These tests are given by both aldehydes and ketones. Okay? These tests, some of the tests are given by both aldehydes and ketones. One of the tests is your Brady's reagent test. Remember this name. What is the reagent? The reagent is 2,4-DNP, which is 2,4-dinitrophenylhydrazine test. 2,4-DNP test, commonly known as 2,4-DNP test, but also its name is Brady's reagent. It has been asked in your JEE exam, so you need to follow this name, Brady's reagent. Okay? So this test is given by both aldehydes as well as your ketones. Remember this thing. Okay? So this is your carbonyl group. So when I react the carbonyl group with 2,4-DNP hydrazine, what I get? I actually get a hydrozone of the 2,4-DNP carbonyl compound. Okay? So what I'm getting? A hydrozone, which is a addition product. What kind of product is this, bacha? This is a addition product that I'm getting. Addition product means what? That from here H2O is getting eliminated. Remember this thing. What is happening here? 1 second. Yes. So what is happening? H2O is getting eliminated from here, and this N is forming a double bond with C. Okay? So this cases both aldehyde as well as ketones give this test. Okay? Next is test given by both aldehyde and ketones. The next test is the iodoform test, as I've discussed already with the alcoholic group. Hai na? So what is the criteria for iodoform test? Like this C double bond O group should be present next to a methyl group. Okay? So on the alpha carbon, there should be a presence of CH3, entire CH3 group. Only those ketones or those aldehydes will actually give this reaction. Okay? So what will happen, bacha? Whenever I react it with excess of iodine, I get a haloform form, which is a yellow precipitate, which confirms the presence of a ketone group or a aldehyde group. Okay? The next is a test given by aldehydes. There are some tests which are given by just aldehydes. Why? Because most of these tests which are going to study are most of the forms of oxidation reaction. Remember, oxidation of aldehydes is easier and oxidation of ketone is difficult. So aldehydes can get oxidized by mild oxidizing agent, but for ketones, you need stronger oxidizing agent to oxidize them. So most of the differentiating reactions between the aldehydes and the ketones are mostly what? Oxidizing reactions. Okay? The number first is shift test. Shift test is not the oxidizing test. This is again an addition product test. So in shift test, only and only your aldehyde. Only an aldehyde give a pink color with the shift reagent. You should know the structure of shift reagent. This is the structure of shift reagent, and when I react it with any aldehyde, what I'm getting a shift adduct form which is magenta in color. Remember this thing. Only and only aldehydes give a shift test. Okay? The next test given by Felling test. Again, Felling test is bacha what? in a Fehling test, what happens? There's a Fehling solution. Fehling solution is actually a combination of two kinds of solutions, okay? And those two solutions are mixed in equal quantities with each other to form one Fehling solution, okay? So one Fehling solution is made by two Fehling solutions, which is Fehling solution A as well as a Fehling solution B. Remember this thing, as well as a Fehling solution B. So this is made by two things, bacha. One second, let me again get the pen. This board is actually not good. Okay, here again Fehling solution B. So what do I quantities together to get one solution? So I am what I'm doing, I'm preparing a freshly prepared Fehling solution. What I'm making a freshly prepared Fehling solution. Okay, so Fehling solution A is an aqueous copper sulfate solution, while Fehling solution B is an alkaline solution of sodium potassium tartarate. Remember all these solutions constituents. Okay, two solutions. Solution A is what? It is aqueous copper sulfate. Fehling solution B is what? Fehling solution B is alkaline solution of sodium potassium tartarate, which is also called Rochelle salt. Okay, now what I do, I mix both these solutions together. Okay, and but generally what is happening, like this is this kind of copper tartarate complex is formed. Okay, this kind of copper tartarate complex is formed when I mix both the solutions. And I cannot also I need to use a Fehling solution. Remember this thing, the Fehling solution should always be prepared a fresh solution before the reaction. Otherwise it gets bad and it doesn't do reaction properly. Like if you cannot store a Fehling solution and then use it further later on for the reaction. No, you have to always make a fresh solution of this by mixing both of these together. Okay, now which only give Fehling solutions positive test? Only aldehydes give, and aromatic aldehydes do not give positive Fehling test. Remember this thing. Again, bacha, what is happening in this case? Your Cu2 plus ions is getting reduced. Your Cu2 plus ion is getting reduced to Cu plus ions. Remember this thing. Why? Because your aldehyde, bacha, what is happening to aldehyde? Your aldehyde is getting oxidized. Can you see? Your aldehyde is getting oxidized to your acid, and therefore your copper 2 plus ion will obviously get reduced. Hai, because oxidation and reduction always takes place simultaneously. Okay? So what is happening? Fehling test. So your Fehling solution is actually a very good what? It is a very good oxidizing agent. Okay? Next. Benedict test. Again, this is only given by bacha what? Only your aldehydes. Okay? Benedict solution is more stable than your Fehling solution. Important point, as it can be stored for a longer period of time. And what is Benedict solution? It is an alkaline solution which has a mixture of copper sulfate and sodium citrate in it. Okay? So this is a mixture of these two solutions. But in Benedict solution, again, what is happening? Your copper 2 plus. What is happening? Your copper 2 plus is getting reduced to copper plus ions. The same thing is happening. Your blue color is changing into red color. What is happening? Your blue colored compound changes into a red colored compound. In both the cases, whether it is Fehling test or the Benedict test, in both the cases your Cu2 plus ion are ultimately getting reduced to Cu plus ions. Okay? Next is your tolerance test. So what is happening, bacha, in tolerance test is, test is given by aldehydes only. Which gives only aldehydes, again give tolerance test. In this we actually use a silver, this is also called a silver mirror test. What do we use? In tolerance reagent is an alkaline solution of silver cation complexed with ammonia. Remember this, a silver cation is complexed with the ammonium ion. This is called your tolerance reagent. Remember this formula. And what happens again? Your Ag2 plus bacha here is getting reduced to Ag plus ion. Okay, and you get Ag0, sorry. What is happening? Your Ag0 ion, and you are getting a bacha what? Here bacha you are getting silver mirror. This is also called a silver mirror test. What it is called? It's called a silver mirror test. Okay, what did I say? Only aldehydes give tolerance test, but there is an exception. that even your alpha hydroxy ketones, which means what? Your sugars, your carbohydrates, which you read, right? Your carbohydrates give positive Tollin test. Why? Because they're alpha hydroxy sugars. So hence, alpha hydroxy ketones actually give positive Tollin test. That's an exception. And other ketones do not give. No other ketone give. Only alpha hydroxy ketone give positive test. Okay? And hemiacetals and formic acid also give this test, but acetals do not. Remember this thing. Hemiacetals and formic acid give this test, but acetals do not give this test. Remember this thing. Okay? Next. Yes, all aldehydes will give Tollin test. Correct, correct. All aldehydes will give Tollin test. Now the next test is the test for carboxylic acid. As the name suggests, it has acid in it, right? So the number first acid for the test of acid, the number first test that we're doing since we were little kids is a litmus test. What happens to the litmus? It turns the blue litmus to red, right? So it turns the blue litmus to red because it is an acidic group. Number second test is the sodium hydrogen carbonate test. What happens in this case, your acid reacts with sodium hydrogen carbonate because your acid is a strong acid, right? Your carboxylic acid is a strong kind of acid relative to what? Other organic acids, right? Other organic acids, not the inorganic. Relative to the other organic acids, your carboxylic acid is a stronger acid, right? So this stronger acid will react with a weaker base. Sodium hydrogen carbonate is a very weak base. It will react with this and form the CO2 gas. And how do we test for CO2 gas? We pass the CO2 gas through lime water and it turns the lime water milky. That's how we know that CO2 is formed. The next is the ester test. What happens in the ester test? We react the carboxylic acid group with the alcohol group. And it forms an ester, which we have always learned this reaction, how to form ester. Acid plus alcohol gives an ester. So this is again an ester test. And what is the specific thing about ester test? It is fruity smelling. Most of the esters are fruity smelling. So this confirms, if fruity smell is coming out, this confirms that the ester was formed. Correct? The next is alcohol, phenol and carboxylic acid. How to distinguish between these two? So as I told you that alcohol, for example, all your alcohols react with what? React with sodium metal to evolve hydrogen gas. Remember this. Okay? But they do not react with sodium hydroxide or sodium hydrogen carbonate. Similarly, your phenols, all your phenols react with sodium metal as well as your sodium hydroxide, but they do not react with sodium hydrogen carbonate. Remember this thing. Similarly, your carboxylic acid reacts with everything. Reacts with sodium, reacts with NaOH and reacts with sodium hydrogen carbonate. Why? Because carboxylic acids are the strongest acids. Similarly, phenols are weaker acid. So they do not react with sodium hydrogen carbonate, but they react with so strong base like NaOH or sodium metal. Similarly, your this alcohol, normal alcohols only react with sodium metal to give hydrogen gases. This is how you can distinguish between alcohols, phenols and carboxylic acids. Okay? Next is the test for amine group. Extremely important. Asked every year in JEE exam. Asked even this year. What happens in the test for amino group? Number first test is the carboxylamine test. What happens? You take your primary amine. Okay? Only given by both aliphatic and aromatic primary amines. Point to remember. Both aliphatic and aromatic, but primary amines give this reaction. So primary amine are reacted with chloroform in the presence of some base, strong base like KOH or NaOH. Then what I get? I get a carboxylamine formed. Carboxylamine is what? Is a isocyanate. है ना? Isocyanate is formed. It is a very harmful chemical. Do you guys know about the Bhopal gas tragedy? Everybody is aware about the Bhopal gas tragedy. If not, I'm sure most of you have seen The Railway Men, which is on Netflix. It's an extremely great series based on the Bhopal gas tragedy and the tragedy that actually caused death of around 15,000 people within one night is actually a isocyanide gas. So this gas which comes out is extremely harmful. You should never smell it, never even bring near to your nose. It is a very foul smelling, bad and very poisonous gas, responsible for death of thousands of people in our own country. Okay, so carboxylamine test is actually an important test for primary aliphatic and aromatic amines, is the thing that you need to remember. Okay, next is your azodite test. Again, your amine test for the azodite test is what? Your aromatic primary amines can be confirmed by the azodite test. Okay, again, this is only for your what? Aromatic primary amines. Remember this. I react the amine with NaNO2 HCl and form a diazonium salt. This is the reaction from your amines chapter. Okay. See, most of the reactions are repeated from your organic chemistry chapter in this chapter. So this should be a revision lecture for you guys. Okay. And if you have not done amines yet, then you won't understand these reactions, because right now I am just giving you a revision session of what all things you need to know for the test, because very direct questions are asked on your JEE and no mechanisms, nothing is asked, so I am not going to focus on that. So what you need to remember, when I react amine in presence of NaNO2 HCl at 0 to 5 degrees Celsius, a very low temperature, I get a diazonium salt. And when I react that diazonium salt with beta naphthol, I get what? This NN actually, this Cl actually goes away and it connects with the ortho position of here. Okay? So HCl, so it is actually giving away HCl, minus HCl goes away, and a diazonium salt. Diazonium salt is azodide, sorry. And azodide is from what is the significance, what is the identification of a azodide? This N double bond N. This N double bond N is the identification of azodides form, and all the azodides have some significant color in it depending on the reagent attached. The reagent here is beta naphthol, hence your azodide will be scarlet red in color. Exact question asked in JEE 2024 again. JEE 2024. What was the question asked? The question asked was like, what should be the reactant where the scarlet red dye is formed? The reactant when the reactant with the diazonium salt, what should be the reactant? The reactant is beta naphthol. So beta naphthol was the answer. Like, with what reactant will I get a scarlet red color dye? So with this reactant. See, so easy direct questions were asked in your JEE 2024 exam. Next is a solubility test for your, again, amine group. What is a solubility test? When I react your aniline in HCl, what do I get? I get a salt. Can you see? Amine group. Amine group has what? NH2 has lone pair of electrons in it. So what are the compounds called which have lone pair of electrons in it? What are those compounds called which have lone pair of electrons in it? Those compounds are called Lewis bases, correct? Which have excess of electrons, which can donate its electrons, are called Lewis bases. Similarly, this HCl is an acid. Can everybody see? HCl is a very good acid. So acid plus base will actually form a salt, right? Whenever an acid and base react, will form a salt. So it is forming a anilinium chloride salt, and every salt, because it is ionic in nature, hence it will be soluble in water. So this is again a very good kind of solubility test to check whether you have a aniline as a compound. Okay? Next is for the amine test. Again, next reaction is the reaction with nitrous acid. Nitrous acid is HNO2. Okay? This is your nitrous acid. So reaction with nitrous acid with primary aliphatic amine. If I react primary aliphatic amine with HNO2, nitrogen gas is evolved. Okay? If I react amine, okay, if I react primary aromatic amine, for example, look at here, which HNO2, what do I get? I actually get a diazonium salt, which I have already read about. Hai na? When I react HNO2 with aniline, I get a diazonium salt. Okay? Now what happens with secondary aliphatic amines, bacha? With secondary aliphatic amines, if I add HNO2, a yellow oily nitrosa amines are generally formed. So you will get a yellow oily layer on it. Similarly, with secondary aromatic amines, bacha, what happened? With secondary aromatic amines, you actually get a R2N NO product. Okay? With tertiary aliphatic amines, there is no visible reaction. And with tertiary aromatic amine, bacha, what happens? Dialkyl alanines yield a green colored product. Remember, green colored solid para-nitroso compounds are formed. So these all reactions are extremely important because this is in 2 of your chapters. One is this practical organic chemistry chapter. The second is your amines chapter. So all these reactions are extremely important and can be asked. They have huge possibility of getting asked in your JEE 2024 exam. Okay. Next, Hinsberg reaction. Again, this is for the test of your amine group. What happens? This is your Hinsberg reagent. Okay, and this is what? This is benzene sulfonyl chloride. This is called benzene sulfonyl chloride. When I reacted with primary amine, can you see this is primary amine in presence of HCl? What happens ultimately? I get an insoluble and alkyl benzene sulfonamide formed. Okay, you have to remember these things. I cannot do anything in it. And then when I reacted with HCl or NaOH, bacha, what happens? It again turns into a soluble salt. Similarly, if I try to react my secondary amine with it, if I try to react secondary amine with Hinsberg reagent, what happens? I get I again get a NN dialkyl benzene sulfonide, but the last time it was soluble in HCl, this time it is insoluble in NaOH. Remember this thing. Okay? Now, with tertiary amines, there is no reaction with the reagent. So, again, these are very, very important reactions. Okay? Next is your, with the, again, amine group. These are some of the reactions which you can see. These are not important, but I've added them for you to check out. This can be your homework. Okay, you will get it in the PDF when it will be shared on the screen. Okay, on your Telegram channel. Now for the test of amides. What happens, bacha, when we are testing for amides? What is happening? So simple primary amides can be decomposed by boiling with alkali. Okay, and it actually gives you a pungent smell. Similarly, they also give Hoffman bromamide rearrangement, which you have read in your amines chapter. Hai na? What happens? The CO group actually gets eliminated as CO2, and what you are left with is a RNH2 compound. Okay, you get a primary amine by Hoffman bromamide degradation. Again, a very important reaction. This is a confirmatory test for amides. Okay, next is test for esters. The very first test is the hydroxamic test. I cannot do anything. What happens in the test of esters? This is an ester group. So all these reactions you must know because they have a higher chances of getting asked in a question. I cannot explain anything. You take a ester group and you react it with hydroxylamine. What happens? You get a hydroxamic acid form. Now with this hydroxamic acid, you react with FeCl3 ferric chloride, and this kind of colored complex is formed. This complex is actually magenta in color, right? So this colored complex confirms the presence of your ester group. Okay? Again, your next test for ester is the hydrolysis of ester, which I've already read so many times. Hydrolysis of ester is also called saponification. What happens? I take an ester and I try to hydrolyze it with a base like NaOH and heat it. And what do I get? I get its constituents, which is an acid and a base. Correct? So I get an acid, salt and a base, and this reaction is called saponification reaction. Correct? Next is your azo dye test. What happens in azo dye test, bacha? I took nitrobenzene. Okay? Now we are here for the nitro group test. So we have already read about the amine group test. Now again, for the nitro group test, there can be again an azo dye test. Why? Because I can convert the nitro group into aniline, right? Now after converting into aniline, I will again perform the azo dye test, which is I again convert the aniline into its diazonium salt, and I react the diazonium salt with the beta naphthol and again get the orange red azo dye or the scarlet red dye. Correct? So this is again can be a reaction of both. This is a reaction of both amines and nitro compound. Next is the Mulliken test. What happens in the Mulliken test? Again, you took your nitroalkane. You tried to react with zinc NH4Cl, and you try to reduce it, and you get a ammonium hydroxide with it. You get a alkyl ammonium hydroxide with it, and it is then cooled and heated with ammonical AgNO3, and then again a precipitate which can be white to gray to black precipitate is actually formed in the presence of nitro group. Okay, everybody got this? Okay, next is when I try to react the alkoxy group with the hot hydroiodic acid or the cold HI test. This is again very important test. You can just look at them and you get to know these tests. Okay, and the tests for carbohydrates are again mentioned. These tests are actually also taught, bacha. These tests will be taught when you will be going through biomolecules, which I'll be teaching you on this channel. I'll be taking organic chemistry on this channel. I've tried to start with this chapter, but I'm not seeing a very great response from the chat right now. I don't know why people are not studying. People have stopped studying now or what? If your exams are over, you're not studying or what? Your next exams are just around the corner. You just have 60 days to cover up for the JEE 2024 blunder that happened, right? So do not take any, even one day for granted. Okay? So Molish test is here, bacha. Okay? Felling test, which will again, so this is how the Felling test is performed. I've actually explained the Felling test to you when we did the Carbonyl, the carboxylic, aldehyde and ketonic group test. Okay? The next is the OSA zone test. Again, this kind of hydra zones are formed. OSA zones are formed with this compound. Okay? So this is again a test for carbohydrates. Then the test for proteins. Can you see it on the screen? The test for protein, the number first is the ninhydrin test. Asked plenty of times in exam. What happens? You should know what is a ninhydrin test. It only reacts. Ninhydrin test is very important. Only those. It is a test for proteins. So proteins is made of what? Amino acids. Only those amino acids actually give the positive ninhydrin test which have a free NH2 group. What do they have? When they have a free NH2 group, only those actually give positive test for ninhydrin test. Okay, and they form a blue-purple color complex. But if the NH2 group is not free, for example in proline, can you see the NH group is actually in a ring and it is not free. Hence this, and this is called the ninhydrin reagent. So this will not react with ninhydrin reagent and it will form a yellow colored compound. And if a yellow colored compound is formed, it means that it has no free NH2 in it, but only if it has free NH2 in it, it will give a violet colored complex. Okay? Next is a xanthoprotic test. Bacha, what happens in the xanthoprotic test? So in the xanthoprotic test, the amino acid that have activated benzene ring. What do you mean by activated? I have explained it plenty of times when we were doing organic chemistry. Activated means what? Activated benzene means benzene ring has too many pi bonds. It means it has too many electrons. So whenever I'm attaching any group, for example, if I've attached a methyl group in it, for example, I've attached a methyl group in it. So what happens, bacha, to the methyl group in it? What is happening to the methyl group? It is increasing the electron density, right? So whenever it is increasing the electron density in the group, what is happening? So what is happening whenever I'm trying to increase the electron density in the group, bacha? What is happening? I'm activating the ring. So that kind of ring where I'm trying to increase electron density, that is called the activating ring. Okay, for example, if I took tyrosine and I try to react it with concentrated HNO3, these kind of products are formed. And if an activating ring is not present, for example, in phenylalanine, there is no activated compound attached to it, hence there is no reaction happening on it. Okay? So the amino acids that have an activated benzene ring can readily undergo nitration. Okay? Because nitration mein bacha, what happens? The electrophile is a NO2 plus electrophile. Everybody is aware of it. And this is the electrophile in nitration. So when will it attack? It will attack that benzene ring which has the maximum electron density in it, which has the maximum negative charge on it, right? Because it is positive. So it will attract the most negative ring. है ना? So the most negative ring will get attracted. But if your benzene ring has no groups attached to it, which is actually increasing the electron density in it, then those such rings, for example in phenylalanine, will show no reaction. Similarly, your Millen's test. What is happening in Millen's test, bacha? Again, Millen's test is specific to phenol containing structure. So wherever this kind of phenol ring is present, only those will give your Millen's test, and a brick red complex with mercury is formed. Mercury 2+ is formed. So only in those amino acids which actually have a OH group attached to it, to the phenyl ring, a phenol group is attached, only those amino acids will actually give the Millen's test. Next is the biurate, very important, very super asked again, which is a very extremely asked question. What happens in biurate test, bacha? In biurate test, positively identifies the presence of proteins. What is it doing? It is identifying the presence of proteins not less than 2 peptides in a strongly alkaline solution. Okay? Example in gelatin, casein and albumin. So what biurate test is used for? The identification of a protein. That is it. Okay? And the protein should be made up of a minimum of 2 amino acids. Okay? So for example, this is a peptide, and when I reacted with copper 2+ solution, I actually get a deep purple peptide copper complex. And if this deep purple complex is formed, this confirms the presence of what, bacha? This confirms the presence of a protein in it. Okay, so here we have completed the qualitative analysis part, and for the quantitative analysis, I might take another session. We've already extended it too much. Thank you for attending the class, and if you like the session or do you have any feedback, let me know in the comment section below and we will get back to you. Thank you for attending the class, and also like, share and subscribe the channel. This is your chemistry teacher Nandini ma'am bidding you goodbye for now. I will see you tomorrow. From tomorrow, our marathon start. Please get back in the josh of your board exams plus your JEE 2024 April attempt exam. Let us get right back into it. We have given you a whole weekend to enjoy. Now the time to enjoy has passed away very, very quickly. Now let us get back to work just like we should, as students, as disciplined students. Thank you so much.